Hi everyone, welcome back to Grade 9 Math. We are going to be continuing to learn more things about the line. So this unit, you guys know we've been exploring various aspects of the line. We've learned about the slope, the x and y intercepts. We've learned about different forms that a line equation can be written in, like standard form and y-intercept form. And last week, you guys learned about vertical and horizontal lines, as well as parallel and perpendicular lines. So we now have gained enough knowledge to start putting those facts and information together, and our ultimate goal is to try and create the equation of a line. And I'm going to introduce that topic today, and that's what you'll be working on this week. So to create the equation of a line when you don't have a graph in front of you, or you can have a graph, but we're going to start off by not looking at a graph. I'm going to break this up into two different scenarios. And so scenario number one is when you've been given a point and a slope. So here is a general equation. Let's say you have some sort of point, x, y, and you have a slope, which is some number, but we're just going to refer to it as m. When you have a point and a slope, you can put that information into something called the point-slope form, which is y2 minus y1 is equal to mx2 minus x1. And this equation, this is very, very important whenever you're trying to find the equation of a line. So I know it has a specific name called the point-slope form, but whenever the question says, find the equation of a line, this is the equation that you are going to be putting it into, or the formula that you are going to be putting it into. And I'm going to show you how to use this formula. Now, some of you may be able to recognize, well, I've seen these letters before. Where have I seen this before? This is just a rearranged version of this formula here. Remember, we used this when we were trying to find the slope between 2 points. And so if you rearrange this and you move this x2 minus x1 to this side, you basically end up getting this formula right here. Okay, so let's look at an example. Example number one says, find the equation of a line with slope 6. So we know that the letter to represent slope is m. I'm just going to write that as m is equal to 6. And it's going through the point negative 1 over 3 comma 5. We also know that whenever we have a point, the first value is the x and the second value is the y. Express the equation in slope-intercept form as well as standard form. And I'm just going to move the sheet over and show you guys or remind you what those two forms were. We have learned about these. The slope-intercept form is the y is equal to mx plus b form. And you're going to recall that the m stands for slope and the b stands for the y-intercept. The standard form is ax plus by plus c is equal to 0. And remember, there are 3 rules related to this. So the 3 rules are, if you want something to be in standard form, it has to be in this order, x, y, constant. You can't have any fractions or decimals, and the very first value, which is the a, cannot be a negative. So we're going to try to figure out the equation of this line given those 2 pieces of information, and we're going to put it into slope-intercept form as well as standard form. Okay, so I'm going to rewrite the information that I know. I know my slope is 6, and I know I have 2 points, negative 1 over 3, comma 5, and this is x, and this is y. I'm going to start by writing the point slope form. So my formula is going to be y2 minus y1 is equal to m x2 minus xy. Now this is interesting because we have y2, y1, x2, x1, but we only have 1 point. So where exactly are we going to be putting those points into? Well, different textbooks, different teachers, different YouTube videos teach it in different ways. I prefer that whenever I have a point, I call it x1 and y1. And so I'm going to be putting this x value over here, and I'll be putting this y value over here. Okay, so let's start substituting our values in. y2, I'm not going to be replacing that with anything. I'm going to leave it as is, and I'm going to write down y2 minus, and y1 is this value right here, which is going to be 5, is equal to m represents slope, which I can see right over here is a 6, bracket x2 minus, because that's part of the formula. And now we have to be careful. Our x1 value is negative 1 over 3. So I need to include the negative sign, and I'm just going to put that in a bracket. Okay, so we have now successfully substituted our values x1, y1, and m. And now you might be wondering, well, I have two different variables. I have an x and a y. Is that okay? And the answer is yes, it's okay. You guys know when you have an equation of a line, you're going to have a y value and an x value, except if it's a horizontal line or a vertical line, then you have either an x or a y. So don't be alarmed. Our equation will have both a y and an x. That is the purpose of it. Now, what do I do with these little subscripts too? Well, in the next step, I don't need to include them anymore. They're sort of like placeholders. They tell you where you're going to be putting in these values. Once you've substituted things in, you can actually drop these little 2's to make it a little bit cleaner. So in the next line, I'm going to go y minus 5 is equal to 6 bracket x. And I'm going to go ahead and clean up these signs. I know 2 negatives make a positive. 1 over 3. Okay, the hardest part is actually done. We have substituted everything in. Now we just need to rearrange our equation into the two different forms. So let's start by trying to put it into slope-intercept form. The first thing I need to do is I see brackets and I see a number in front of the bracket. So automatically I'm thinking distributive property. I'm going to take that 6 and I'm going to distribute it inside of the bracket. Y minus 5 is equal to 6x, because 6 times x is 6x. 6 times positive 1 over 3. In this case, we're lucky it ends up being a positive 2, a nice whole number, but it could end up being a fraction. And I have an example where I'm going to show you what that looks like. Okay, and then finally, to make this into slope-intercept form, I just need to get rid of this negative 5 and move it to the other side. So it's going to be y is equal to 6x plus 2. When the negative 5 moves over to the other side, remember the sign or the operation changes, so it's going to become positive 5. And then finally, y is equal to 6x plus 7. That is the equation of this line in slope-intercept form. I'm not done because the question says we also need to rearrange it and put it into standard form. Okay, so for standard form, the easiest thing is you always want to have your x value be positive. So right now it's a positive 6x. I want to leave it on this side. The easiest thing for me to do is move this y, sandwich it right between these two terms, and if it's a positive y, it's going to become a negative y. So 0 is going to be equal to 6x minus y plus 7. And remember, when we were teaching you this, you can write it in either form. Like you can have all these terms on the right or the left. It doesn't matter. And in this case, it was just easier to move everything over to the other side. Okay, we're ready to move on to question number 2. Question number 2 says, find the equation of a line with slope negative 2 over 5, which I've written down over here. M is equal to negative 2 over 5, and through the point 1 comma negative 2, which I've written down here. It's the exact same question as before, except this time I wanted to show you how to deal with a question that has a fractional slope. We will be expressing the equation in slope-intercept form and standard form just like we did before. So let's recall our formula that we're going to be using. The point slope form is y2 minus y1 is equal to mx2 minus x1. We also know when we have a point, we're going to label it x1 and y1. Although I should note that if you were to label this x2 and y2 and put it into this part of the formula, you wouldn't be wrong. You would actually end up getting the right answer. But just from experience, I know that putting it into x1 and y1 is more beneficial, and it just helps you when you are rearranging the formula. So let's go ahead and substitute our values. We don't have anything to substitute into y2, so we'll leave that as is. We're going to keep the negative sign. It's part of the equation. And then y1 is negative 2. Be very careful of those double negatives. Is equal to, our slope is negative 2 over 5. We don't put anything into x2 minus, and x1 is this point right here, which is just a 1. In my next step, I'm going to go ahead and clean up the sign. So you're going to notice that you have the double negative over here. And I'm also going to go ahead and drop my subscripts for the y's, the 2's. I don't need them anymore. So this is going to become y. a negative and a negative is positive 2 is equal to negative 2 over 5 x minus 1. At this stage, you can recognize that we have a number outside of the bracket, so we're going to go ahead and use the distributive property. So you're going to multiply this fraction by the x and this fraction over here by the negative 1. Okay, so when I do that, I'm going to get y plus 2 is equal to negative 2 over 5x, and negative 2 over 5 times negative 1 is positive 2 over 5. Let's go ahead and put this into slope-intercept form first. So I know that to get it into slope-intercept form, I just need to get rid of this positive 2 and move it to the side. So I'm going to be left with y is equal to negative 2 over 5x plus 2 over 5. When I move this over, it's going to become a negative 2. Okay, so I just need to clean these two numbers, these two constants up. And to do that, just because I'm running out of room, I'm going to go over here to my rough area, and I'm going to figure out what positive 2 over 5 minus 2 is. So let's go ahead and try that. Positive 2 over 5 minus 2 over 1. I know that these are fractions that I need a common denominator for, so I'm going to go ahead and multiply both the top and the bottom by 5. And I will get 2 over 5 minus 10 over 5, which simplifies to negative 8 over 5. So this fraction over here, minus 2, gives me negative 8 over 5. Y is equal to negative 2 over 5x minus 8 over 5. That is our equation of a line in slope-intercept form. We are not done the question yet. We need to go ahead and try to figure out what it would be in standard form. Okay, so let's start with y is equal to negative 2 over 5x minus 8 over 5. You're going to remember a couple of lessons ago, we practiced going from one form to the other, and it was all for this moment right here. So what I like to do is whenever I have a bunch of fractions, I like to use my magic number and try to get rid of those fractions. I see my denominators are both 5, so that's pretty easy. I know I'm going to be multiplying by 5. 5 times y is going to give me 5y. 5 times negative 2 over 5, when you do the math, it's negative 10 over 5, which actually ends up just being negative 2x. And then 5 times this fraction here will be negative 8. Now, to get this into standard form, I notice that my negative 2x is over here. If I move it over to the other side, it's going to become positive 2x. Now, I always like my equal signs to line up. It's just I'm running out of space, so this time they won't. But the good format is always to have all your equal signs perfectly aligned. So when I move the 2x over to the other side, it's going to become positive 2x. This positive 5y stays where it is. I also move the negative 8 to the other side, and it'll give me positive 8 is equal to 0. And that's our answer in standard form. All right, let's go on to our last example for this lesson. Example number 3. Find the equation of a line with slope 0 and through the point negative 4, 7. Express the equation in standard form alone. This is interesting. Slope 0 and point negative 4, 7. Now, you can do this question in one of two ways. You can do it the traditional way that we have been doing all along, and I'll show you that first. So hopefully by now, by this example, you guys are getting the hang of it. We'll do this part a little bit quicker. So it's going to be y2 minus 7 is equal to 0, x2 minus negative 4. Okay, let's clean this up a little bit. And then let's pause. I have a 0 times this entire bracket. If I distribute the 0 or any number multiplied by 0, I know is going to be 0. So this value right here becomes a 0 automatically. I don't need to do any more math. And because it needs to be expressed in standard form, I actually already have it in standard form. I have y minus 7. So our final answer would just be y minus 7 is equal to 0. The math is super easy because you're dealing with a 0, which actually gets rid of a lot of stuff. But what if I told you to do this question by sketching a graph, not by using math? I actually think doing this question by sketching a graph is easier Because let's look at what happens. Okay, so I'm going to just do this rough. If you have graph paper, even better. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Not very accurate. Sorry about that. Let's label point -4, 7. So -4, 1, 2, 3, 4, 5, 6, 7. It's going to be about over here. Okay. What kind of line has a slope of 0? You learned this last week. I know that a horizontal line has slope of 0. And I also know that vertical lines have an undefined slope. I mean, we don't really need to know this information right now, but it's just good to review. So if I know my horizontal line has a slope of 0 and this is a slope of 0, this line over here has to be a horizontal line. How do I find the equation of a horizontal line? Well, I just look at what axis it's going through. It's going through the y-axis. And what point is it going through? It's going through the point 7. So the equation of this line is y is equal to 7. This is not in standard form. I need to move the 7 over. Y minus 7 is equal to 0. That would be this equation in standard form by looking at it as a graph. You could do it either way when the slope is 0.